Hey everybody, it's Mr. N, and we have another quick online review, a couple multiple choice questions. So let's go ahead and get started with this. So the first one says, determine the area enclosed by the curves y equals 2x squared minus 4x plus 4 and x squared minus 6x plus 5. All right, so let's take a look at what we have here. So since this is no calc, what I suggest on this is taking a look at these two curves to try to determine which is the top curve and which is the bottom. Now you can plug in various points. You could start with 0, you'd start with 1, you could start with 2, whatever. Just easy points to try to get values to see which is greater. And when you do that, if you plug in, say the point 2, and you will find out that this ends up right here being the bottom curve, and this ends up being the top curve. Now, I would suggest plugging in a few extra values. In fact, what I would suggest is first finding the intersection points, and then trying to find a value between the two intersection points. What you will end up with is this is going to be a little bit skinnier curve, and that one and this one will be this top one that I listed as a top will be a little bit wider. So you will have the two curves that intersect somewhat like this, and with this one being the top right here, and this is the bottom. And because this bottom one is a little bit skinnier, that's why it intersects. That's what ends up happening. But we can find the intersection points, and let's go ahead and do that. So what we want to do is we want to set these two equal to each other. And this equals the x squared plus 6x minus 5. Let's go ahead and solve this. We'll get x squared minus the 10x plus the 9 equaling 0. And we can factor this. We get x minus 9 times x minus 1 equals 0. So we end up with the intersection points at x equals 1 and 9. Now, let's plug these back in to the originals, and we will, I did this quickly on the side just for this video, and we went ahead and got the points 1, 2, and the next one will be 9, 130. And then, like I said, you could plug a point in between 1 and 9 to verify which is on top and which is on bottom. The reason why I say that is because if you flip-flop these in your integral, you will get a negative answer. But you can go ahead and do this and get a negative answer and understand that, well, this is not the correct one, and just change that to a positive. So let's go ahead and set up our integral. I'm going to move this up a little bit more here. So let's find out what this will be. So these are the two intersection points. So this is 1, 2, and this is 9, 130. So we have the integral from 1 to 9, and this is going to be the top minus the bottom, right, dx. So we have the integral from 1 to 9, and the top curve in this case is going to be the x squared. So this x squared plus 6x minus 5 minus the bottom curve, which is the 2x squared minus 4x plus 4 dx. Now, cleaning this up, this ends up being negative x squared plus the 10x minus the 9. So when I integrate, I will get, this ends up being negative 1/3 x cubed plus 5x squared minus 9x on the bounds from 1 to 9. So let's go ahead and solve this. So I'm going to put in 9 cubed divided by the 3 is going to be negative 243 plus 9 squared, 81 times the 5 will be 405 minus the 81. Subtract this from negative 1/3 plus the 5 minus the 9. This comes out to be 81 minus 13, or this will be plus, sorry, because this ends up being negative 13/3. Yeah, so this ends up being plus 13/3. So I will end up with common denominator of 3. This will give me 256 over 3 as my final answer, which is D. Okay, so I did that kind of fast, but you're going to have to do some of these multiplications, and this will end up happening on the AP test. You will get some numbers you have to multiply and add. So just be careful and double check yourself. All right, so let's move on to the second one, and let's see if we can squeeze this in a little bit. Let's move it, make it a little bit smaller so we can see it all. Okay, there we go. All right, so it says find the volume. It says of air in a balloon. V of t is given by the function v of t equals that. From 0 to 5, where t is the time in seconds. Find the rate in cubic units per second at which the volume of the balloon is changing at t equals 4 seconds. Okay, so here, this is a basic rate problem, and we want the volume changing, so that means we need a dv dt. Well, that means we need a v prime, right? Because that's a dv dt is equal to a v prime of t. And in this case, I'm given this equation, so let's take that derivative, and that derivative is just going to be negative 4t. All right, but now it says at, right here, t equals 4 seconds, so this becomes negative 4 times the 4, which will give me negative 16, and that's units cubed per second, but they didn't ask for that, so here is our answer C. And that was pretty straightforward, but just understanding that this is a rate problem. All right, so thanks for watching. Hit that like and subscribe button, and I have more of these videos coming. See you soon.